All right, let's look at multiplying rational numbers. So the good thing about multiplying rational numbers is it's exactly like multiplying integers. If my signs are the same, my answer is positive. If my answers are different, my answer is negative. So the rules are exactly the same as they were for integers. Just be careful that you don't use the addition rule there. You don't do big minus little or anything like that. You just use it to find the sign. And just like with integers, we look at number lines. Again, number lines are really good at showing why things work. They're not so great at showing answers, but they represent the process very well. Here's what that looks like. Let's say I do 3 times 1/2. So what 3 times 1/2 means is that I'm going to do that 3 times, or I have 3 groups of 1/2. Notice that vocabulary. 3 groups of 1/2. I'm going to start my number line here at 0. 2, put 1 right there. 1, 2, 2 right there. Don't have to go very far. So I've got 3 groups of 1/2. So starting at 0, I'm going to go 1/2. There's 1 1/2, 2 1/2, 3 1/2. So altogether, it's 1 1/2. So the number line does a nice job of showing you grouping and why things work. Another way you can look at it is I've got 3 things and half of each. Half of 3 things. If I combine those, these two equal 1 whole thing. This is another half. So my answer is 1 1/2. Another way of looking at that. For number 2, our second example, let's see what happens with a negative. I'll do 5 times negative 1/4. Start at negative 2 and go 1, 2, 3, 4. Puts me at negative 1. 1, 2, 3, 4. Puts me at 0. That's really all we have to do. So this says that we're going to go negative 1/4 5 times. So we start at 0. We're going to go 1/4 5 times. Once, twice, 3, 4, 5. Takes us right there. So it's negative 1 and 1/4. I actually kind of like the number lines for these because it shows why they work really well. I love thinking of multiplication as groups of. 3 groups of 1/2. Half, half, half. This is 1, 2, 3 groups of a half. So I think it's a smart way to think about the problems. However, they're not very good at solving big numbers. That's why we use algebraic methods to solve bigger problems. So solving fractions, we're going to do numerator times numerator, and that'll equal our numerator. Then to get the denominator, we do denominator times denominator. That equals our denominator. The only really important fact, no mixed numbers. You cannot multiply mixed numbers like this. There are people in the room that are going to try to do that. Be very careful. You have to do fraction times fraction to get your fraction. Let's do that. So if we cannot use mixed numbers, we change it to an improper fraction and then just multiply straight across. Let's look at a third example. Let's do 6 times 1/3. Now this one's not a fraction. What do I do? Remember we said we have to have two fractions in order to multiply fractions. Lena? Perfect. And when a number is against the parentheses like that, it does mean multiplication. 6 times 1 gives us 6. 1 times 3 gives us 3. 3 goes into 6 2 times with nothing left over. So our answer there is 2. Yes, you do have to reduce. Looks like 12 is 2. Let's look at one with a negative. One-fourth times negative 2/3. Is my answer going to be negative or positive? Negative. Thank you. So now that I know my answer is going to be negative, I'm not really worried about that sign anymore. It doesn't really make a difference in solving the problem. 1 times 2 gives us 2. 4 times 3 gives us 12. And now we reduce. 2 goes into 2 once. 12 divided by 2 is 6. So our answer there is negative 1/6. All right, let's have you guys do one. Let's see you do negative 1/8 times negative 2/5. Multiply those together. Anybody think they got it? Allie, what'd you get? And how did you get that? And 2 goes into 2 evenly. 2 goes into 40 evenly. Was your answer positive or negative? Why was it positive? Very good, yes. Yes, ma'am. What? Uh-huh. I'm not Oh, like when you get here, you could flip it over. I don't know what that is. I know sometimes when you do division, they do like you'll flip over one number, but I can't imagine doing that here. We will talk about reducing in the problem, which is kind of confusing, but we're not quite there yet. Let's look at a danger problem. Yeah, it's a danger. It's a dangerous problem because it has a mixed number in it. It has a mixed number. What do I do? Yao? There you go. I'm gonna multiply and then add. A lot of teachers use that check mark method. Works fine. 2 times 4 is 8. 9, 10, 11 over 4. Denominator stays. Then I'm going to multiply that by negative 1/2. Positive times a negative is negative. 11 times 1 is 11. 4 times 2 is 8. 8 goes into 11 one whole time, with 3 left over. Denominator stays the same. Yes, you have to reduce every single time. Last thing we're going to look at, decimals. The good news is that decimals isn't a whole lot of new information. You just multiply regular, and then you just count behind the decimal. So if I'm multiplying decimals, if I'm doing this, yeah, I designed it. So multiplying decimals is just like normal multiplication. I got a positive times a negative, so my answer is going to be negative. And then I'm just going to do 3.5 times 2. Line everything up to the right side. Multiplication, that's what you do. 5 times 2 gives us 10. 2 and 3 gives us 6, plus 1 gives us 7. The difference here is that you have to count the number of digits behind the decimal. In this one, there's one number behind the decimal, so we slide this forward 1. So our answer there is 7. Somebody earlier today was really confused because they thought you line up the decimals. It still works if you line up the decimals. 3.5 times 2.0. 0 times 5 gives us 0. 0 times 3 gives us 0. Placeholder. 2 times 5 is 10. 2 times 3 is 6, plus 1 gives us 7. So we add those together. Now there are 2 numbers behind the decimal, so we move it 1, 2 places. Get the exact same answer. I heard a rumor that your grade level in the entire building is not very good at multiplying 2-digit numbers. I don't think that's possible because I've seen you guys multiply and you guys are really good at it. I don't know if it's true or not. That's just what I heard. Negative times a positive is a negative. Let's prove them wrong. So 1.6 times 1.5. 6 times 5 is 30. 5, 6, 7, 8. 0 is a placeholder. 1 times 6 is 6. 1 times 1 is 1. 0 is 14. 2. We have 2 numbers behind the decimal, so we move it 2 places. So it's now 2.4. So decimals just multiply normal. And then you just have to count up the number of digits behind the decimal. That's how many you move them over. For fractions, all you do is numerator times numerator. That's it. These are the kinds of problems that get easier the more you do. So that's why we'll be doing a lot of them. Any questions about problem today, or any questions about the notes?